Welcome back to our live training session here. We're going to be taking a look in this tutorial at how to dial in our part throttle driving area. This is going to be looking at how to calibrate our VE table, dialing in our airflow model to get our fueling correct. Also taking a look at our spark timing, trying to find maximum brake torque with our spark timing to get the optimized torque output out of our engine. And then we're also going to be taking a look at things like our variable valve timing control in our part throttle situation for a Honda K series engine, as well as our injection timing. So we have a lot of things to unpack and discuss here in this tutorial. The first thing I want to bring attention to and cover in the tutorial is going to be what we were having an issue with in the last tutorial, and that's the variable valve timing control. Let's jump in and talk about that. We're going to be talking about setting up our intake target position table for our low cam. Remember, we've set up everything for low and high cam, so we have two tables for VE tables, spark timing tables, variable cam control tables. We want to do this to properly characterize our K series engine, and this is the exact same way that Honda calibrates using the factory ECU. They make sure that they have the ability to go in and being able to characterize both low and high cam operation, VTEC, non-VTEC. All right, let's take a look at this real quick. So jumping up under engine functions, we're going to take a look down here under VVT cam control. Now, we're going to be firing up the engine here in just a second to take a look at this process of calibrating, if we go in here, our cam position offsets. So we have this position offset. Right now we had it set at 44.4 degrees ATDC, and this was incorrect. And the reason why it was giving me problems is because this value has to be a much higher value. I was trying to enter negative values to get the absolute position zeroed out. So when the target was 0, we want to see 0 in the actual cam position tracking, and it won't let me put a negative number in, which means that I have to go back in the rotation. So we have 0 to 720 degrees of values that we could place in here. I have to go and swing it back the other way. So if I'm off by, let's say, 44 degrees, 45 degrees, I have to go from 720 and then subtract another 44, 45 degrees. We're going to get into how to do that here in just a little bit, but there was giving me some issues. And the reason why I suspect that this value is way off from where I would normally expect the range to be at. Typically, I see values in here 0 to, let's say, 50, 60. I typically don't see values that are something like 650, 700 values. I think it's because the cam crank pattern that we have selected. Recall that we couldn't get the engine to go and fire up on the Honda K20 pattern. I had to select the Honda K24 pattern that got the engine to fire up and run. And by doing that, it must invert an edge looking at our signals within the pattern. I'm not exactly sure what's going on with the selection when we select that OEM default pattern, but that is why I suspect that there's probably a big discrepancy here looking at our cam position offset value. So no big deal, we'll sort this out here. Again, we're gonna come in here in a second and actually get the engine to fire up and run and go through that procedure real quick. It's actually straightforward. Once I realized what was going on off camera, I tested it out, and again, I'm gonna demonstrate that. But let's go in here and take a look at our cam target table. So we have two tables that we're gonna be dealing with. We have a target table 1, target table 2. Now, both of these tables are identical in their shape. We've based these tables based on efficiency calculation %, which is going to be throttle position. We can see here as I go and move my throttle input, we see that's tracing in the table there, following along that axis. It's also based here on engine speed. So these two tables are identical, and we've zeroed out the tables just to have a starting point when we're building our base files, not to complicate anything. Now let's talk about what we need to actually put into the table here to start to populate this and get more appropriate values specifically for a part throttle operation. We're not worried about wide open throttle right now for low cam. And again, table 1 is low cam, table 2 is high cam, and we've designated between these two tables using the Z-axis function. So if we go down here to Z-axis setup, we have this set here on cam switch status, which is VTEC. So cam switch status 0 means low cam VTEC off, status of 1, VTEC on, and therefore we call out cam status 0, VTEC off, not engaging it, position table 1, and then 1 here, position table 2. So hopefully it makes sense in terms of the logic. And we look here into the cam control, we've set it here to the Z-axis option 6. So that's how we set this up in that base map, just to do a little refresher here. So let's jump in and take a look. Now, when we're in part throttle situations, we want to lock into about 30 degrees of variable cam timing. That's about the ideal sweet spot for variable cam control. So when we're here, let's say roughly at 10% throttle, up to about maybe 50, this is all we're really focused on. And I'm gonna say here from about 2,500, so in this range, up to like 5,000, 6,000 RPM. So in this range right here, this is gonna be what we command at 30 degrees. Now, I wanna tweak this table just a little bit in terms of the breakpoint axes. I want to go in and set this at 0, maybe 5, and then 10%. I'm going to explain why here in just a second, but let's go in and use the A function, A button. That's going to bring up my axes here, and we're going to go into our y-axes, allowing us to edit our efficiency calculation. I'm going to set one here at 5, then one here at 10, and then I'm going to go and click OK, click yes, and then we'll flip over to our z-axes. And in this table, it doesn't really matter. We don't need to be as specific with the breakpoints, so it's not a big deal. But let's go back here to our table 1. Now, why did I do this? Because I want to make sure that when I'm in my lift throttle or overrun where I'm off throttle, so 0, the cam target here on OEM cams is going to be 0. So we want to make sure that's 0. And then when we're going here between, let's say, 0 and 10%, so 10% is on throttle, we want to make sure that we're transitioning our cam target. So it's going from 0 to something like, let's say 15 to then something like 30. So we want to have a progressive cam target as we're calling out through our breakpoints here to allow the cam control a little bit more smooth application of that variable cam movement. So let me go and just populate the table here. So I'm going to go from 10 to 50, maybe even 60 is fine for right now, and go up here to about 6,000. We're just putting some kind of a value in here to get going. Now 30 degrees, we have in this case, I have a 50-degree VTC gear fitted to my engine. I'm in part throttle going to be commanding 30 degrees. 30 degrees seems to be the sweet spot for any K-Series engine, any K-Series camshafts you might be running that's retaining variable.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.